Today's notes are 2.1, Key Features of Linear Graphs. The learning target is I can identify the key features of a linear graph those features being slope, which is m, x-intercept, y-intercept, which is b, domain, and range. Natalie has signed up for yoga classes at her local gym. It costs her $12 to join and then $3 for one class a week. The yoga class special is running for 4 months. Use this in order to create data points, create a table and a graph of this data. So we're obviously going to be using this graph over here on the right. Now if we look at the units, the y-axis is money spent on yoga classes. The x-axis is number of weeks. Now the information we were given was in months, so it might be really useful to turn that to weeks. 4 months is 16 weeks. Now the first thing that we were asked to do was to create a table. So let's go ahead and do that. Grab your straight edge and create a table for your x and y values. My x's are weeks. My y is money. Okay, so we start at the 0 week. We don't really count the first one as 1, count it as 0. For her to initially join, the very first time she goes to the gym, it's going to be $12. So at week 0, she's paying $12. And then $3 for every one class a week. So at 0 weeks, she pays $12. At week 1, she's going to pay $3 more, which puts us at 15. At week 2, $3 more, 18. Week 3, $3 more, 21. Week 4, $3 more. Week 5, $3 more. So she's going to keep paying in intervals of $3. Let's make this table. 15, do 18. 321, 424, and we can keep going all the way up to 16 weeks. Now, is this situation being the keyword, discrete or continuous? Should we connect these dots? Should we connect these points with a line? Why or why not? Now, the data is number of weeks she attends a class and the amount of money she spends on the classes. Now we're going to say this is discrete because you can't pay, or you're not going to attend part of a class. You either attend a whole class or you don't attend a class at all. So because you cannot pay for part of a class, do not connect with a line. What is the rate of change? So what is the rate of change? What's another word for rate of change? Slope. So our rate of change, we go up 3 units and over 1. So if we look back at our problem, this is $3 for 1 class a week. So our rate of change is going to be $3 per class. Now what does the rate of change represent in this situation? Well, if it's $3 per class, it's the cost per yoga class. How is the rate of change in this situation visible in the graph? What do we call the rate of change on a graph? Well, what type of correlation does this data have? It has a positive correlation, which means it's increasing. And what do we call the rate of change on a graph? Well, the rate of change is our slope. We mentioned that earlier. And just as a reminder, it's m. What is the x-intercept? What does the x-intercept represent in the situation? As a quick reminder, the y-intercept is where our data crosses the y-axis. Our x-intercept is going to be the same thing. Our x-intercept is going to be where the data crosses the x-axis. Now, if we were to draw a line through this data, our line would extend to another quadrant of the graph and intersect our x-intercept over here on the negative side. But since we don't really think of time as a negative, we're going to say this is not applicable. What is the y-intercept? What does the y-intercept represent in this situation? Well, like we just mentioned, the y-intercept is where the data crosses the y-axis. So our y-intercept is this point here, which is the coordinate 0, 12. And what does that mean? What does 0, 12 represent? What was our very first, or our initial point? That was the cost to join the gym before paying for any classes. Before being the key word here. What is the reasonable domain for Natalie's situation? Are there any values that would be unreasonable to include? Domain are your x's. So what are the possible x values for this problem? Now we want to make a list, right? Our x's are our number of weeks. So how many weeks are possible in this problem? Well, at the very beginning, we said it was 4 months long, which translated to 16 weeks. So this problem can only go up to 16 weeks. We want to list our domains. And what was the very first thing that we needed in our lists? it was the braces. So make sure you write your list and don't forget your braces. We started at week 0. Then 1, 2, all the way to 16. Now, are there any numbers that aren't reasonable to include? And we're going to say partial numbers because we are paying for the membership in terms of weeks, not by the number of days she goes in the middle of a week. So if she goes 1.5 weeks, she's going to go ahead and pay for the whole 2 weeks. Or if she goes for 1.1 weeks, she's still going to go ahead and pay for the whole 2 weeks. Now, domain is X values. What is a reasonable range for Natalie's situation? Are there any values that would be unreasonable to include? If domain is X, that means range is Y. So range are Y values. So looking at this part of the graph, what values on our y-axis did we use or were included? Well, on our data, what was the smallest y value? It was 12. And then we went up 3 every time. 15, 18, 21, 24, 27. And we're going to do that 16 times. So again, it is a list, so make sure you include your braces starting at 12, going up by intervals of 15. Now, any values that would not be reasonable to include would be anything over 16. Now, any values that would be unreasonable to include would be anything over 16 weeks. So, write an equation of a function of notation to represent this situation. Well, our equation just needs to be an mx plus b. We've identified our m, we've identified our b. Let's just write our equation. Y is equal to 3x plus 12. Now let's take apart the notes. Ms. Becker is taking a trip to see a family in Kansas. Her gas tank will hold a maximum of 15 gallons of gas. She will use 3 gallons of gas each hour she drives. Use this scenario to create a data, points, create a table, and graph this data. Looking at our x-axis, that's hours of driving, so let's create our table. X-axis is hours. Y-axis is gallons of gas left in the tank. So let's just say gallons. X and Y's. So her gas tanks hold a maximum of 15. So that means without her driving any hours, she has 15 gallons. So at hour 0, it's 15. She will use 3 gallons of gas each hour she drives. So after 1 hour, what's 15 less than 3? It's 12. After 2 hours, 9. After 3 hours, we can go 1, 2, 3 over 1. 6. After 4 hours, 1, 2, 3 over 1. 3. And after 5 hours, 1, 2, 3 over 1. So this is our data set. Now let's put it on our table. That was 112, 29, 36, 43, and 50. Is this situation discrete or continuous? Should we connect these points with a line, and why or why not? Does it make sense to be in between our data, in between our points? Does it make sense to be in between our points? So if Ms. Becker is driving to Kansas, can she only drive in whole increments? Meaning, can she only drive 1 hour? Is she not allowed to drive less than an hour or more than an hour? And her gas tank, can her gas tank only hold for the Y values? Does it make sense to be in between? So can the gas tank only hold gallons by 3s? Can it only hold 15 gallons? Can it only hold 12 gallons or 9 gallons? Or does it make sense to be between? So let's say for Ms. Becker it only takes 2.5 hours to drive to Kansas. That makes sense. She can drive 2.5 hours. Can her gallon hold 8.73 gallons of gas? And it all makes sense. So because we can say that, we can say it's continuous. Hours and gallons are both measurable in parts. Connect with a line. And that's what we're going to do. We're just connecting these points with a line. So what is our rate of change? Well, starting at one point, we go down 3, which makes it -3, and over 1. And what is it that's changing? It's the number of gallons that is changing. So -3 gallons. And what does the change represent in the situation? Ms. Becker loses 3 gallons of gas for every 1 hour, or each hour. So -3 gallons for 1 hour. How is the rate of change in the situation visible in the graph? What do we call the rate of change on the graph? Well, the rate of change is making the graph decrease. So decreasing slope. And what do we call the rate of change on a graph? So what is the x-intercept? Where does this data cross the x-axis? At 50. And what does it mean? It means that after 5 hours, after she's driven 5 hours, she has 0 gallons of gas left. So after 5 hours of driving, she has 0 gallons. What is the y-intercept, and what does the y-intercept represent in this situation? The y-intercept is 0, 15. That means before she drives at all, not drives, she has 15 gallons of gas. What is a reasonable domain for Natalie's situation? Are there any values that would be unreasonable to include? Now, since we are able to have parts of a measure, meaning the minutes between the hours are included and the measurements between gallons are also included, we're going to have to write this as an interval. Her domain are the x values, which our x's are hours of driving. So what's the most she can drive in 15 gallons? The most she can drive is 5 hours. So anything between 0 and 5 can be included. And we will say h for hours. She can drive more than 0 hours, but no more than 5 or up to 5 hours. So this is the min, this is the max, and anything in between. And what is the reasonable range for Natalie's situation? Are there any values that would be unreasonable to include? So now the y values. Now again, our y values is number of gallons in the tank. So the least amount of gallons she could have is 0, and the maximum amount of gallons she could have is 15. So the possible range for gallons is 0 to 15. So this is the minimum, and this is the maximum. And write an equation in the function notation to represent the situation. Y is equal to negative 3x plus 15. So we found our slope and y-intercept earlier. Just put them together to make the equation.